Bob. Sorry, get all this on tape. So that's what I will be using. Let's take 5.1, the ophthalmic division of the trigeminal, which you will recall enters the orbit through the superior orbital fissure. And of course, it is a large sensory nerve. It immediately breaks up into a number of components which are represented on the face and traverse the orbit to get there. Starting most laterally is a branch, the lacrimal, which actually pierces the lacrimal gland and is represented on the face on the superolateral quadrant of the orbit. Next is the frontal nerve, which actually bifurcates into a supraorbital and supratrochlear. You recall there's a supraorbital groove or foramen along the superior margin of the orbit, and supratrochlear is just above the trochlear for the superior oblique muscle. There is a third branch, which is the nasociliary. The nasociliary runs most medially, sends a sensory branch into the posterior ethmoidal air cells, and ends as a branch just below the medial angle or canthus of the eye, the infratrochlear. A side branch entertains the anterior ethmoidal cells with sensory innervation, and therefore is internal. It's often called the internal nasal, but it soon presents itself externally as the external nasal. From the nasociliary, there are a number of so-called long ciliary nerves which enter the back of the eyeball to provide sensation from the cornea, from the iris, and from the ciliary body. The cornea is exquisitely sensitive. You know this. A poke in the eye is readily perceived. Thank you. These are the more advanced students laughing. They learn this later in their education. However, there are other components that are running with 5.1. And these are derived from the oculomotor 3. Now, the oculomotor 3 is a motor nerve for the most part. It too enters the superior orbital fissure and immediately divides into a superior and an inferior division. Now, we know that the oculomotor serves the levator palpebris superioris, the superior rectus, the medial rectus, the inferior oblique, and the inferior rectus. Fine, we don't care about that. What we're interested in is the fact that in addition to these somatic motor fibers, there is running with 3 some preganglionic parasympathetics. And hanging off the inferior division is a ganglion, the ciliary ganglion, which in fact most of you found, or at least claim to have found. Synapsing with the secondary cell bodies in this ganglion, postganglionic parasympathetics are conveyed via the short ciliary nerves to the ciliary body and the ciliaris muscle, which is active in accommodation, and also to the constrictor pupillae, also activated in accommodation. Wherever you have parasympathetics, count on it that you will have sympathetics. The sympathetics derive, as you know now, from spinal outflow between T1 and L2. They ascend in the neck, howsoever, as the cervical sympathetic trunk, and then at the superior cervical sympathetic ganglion is their last chance for synapse. Sympathetic fibers after that are postsynaptic, and they get into the skull by creating a periarterial sympathetic plexus. A twig from this plexus accompanies 3 passes right through the ganglion and is distributed via short ciliary nerves to the antagonist to the constrictor pupillae, which is the dilator pupillae. Likewise, these sympathetics serve smooth muscle in the vasculature of the eye, as well as Mueller's muscle, that smooth muscle in your eyelid. It might be known, for completion's sake, that sympathetics do also follow the long ciliary nerves as well. And finally, there is a so-called sensory route to the ciliary ganglion, a sensory route. There is a branch that comes down like this, and so that in fact all short ciliary nerves likewise convey sensation from the cornea, iris, and ciliary body. They're beginning to look glassy-eyed. I don't hear any chokes or gags. That's simple. That's very simple. Where life gets complex is when we address 5-2, the maxillary division of the trigeminal. This involves that veritable queen of spaces, the pterygopalatine fossa, represented. Yes, the queen of spaces, the pterygopalatine fossa. This is the weirdest anatomical. I mean, do you think that back of the view oropharynx that I draw that Lee doesn't like, he thought that was weird? Look at this one. I mean, the whole board is canted with anterior up there and posterior back that way, and lateral down here, medial up here. The pterygopalatine fossa totally dominates the skull. It's a room exploded with 4 walls. And there's kind of a little orbit in front and a nose with a septum and a little crista galli. Lee said he thought that looked like Mount Washington. Whole thing's hopeless. But this is it, ladies and gentlemen. This is the key. This is the key to understanding the neurovascular distribution of the head and neck. Because through the foramen rotundum, the maxillary division of the trigeminal 5-2 gains access to the pterygopalatine fossa and lies then centrally within it. From this point, sensory fibers can course in all directions, including anteriorly through the inferior orbital fissure, passing via the infraorbital or the floor of the orbit and appearing below the eye as the infraorbital. A lateral branch of the infraorbital ascends the lateral wall of the orbit, divides, passes through the zygoma as the zygomatico-temporal and zygomatico-facial. Thus this area are presented and covered by 5-2. Laterally, a branch passes out the pterygomaxillary fissure and so provides sensation to the upper gums and teeth as the posterior superior alveolar. There is indeed an anterior superior alveolar, which is a branch of the infraorbital descending through the maxillary air sinus and providing innervation to the upper teeth. And here it is right here. But most of it is taken by the posterior superior alveolar. An inferior branch of 5-2 passes down the greater and lesser palatine canals and so provides sensation to the soft palate and to the hard palate. And finally, a medial branch courses through the sphenopalatine foramen into the nasal cavity. A midline nasopalatine nerve courses down the nasal septum and appears out through the incisive canal just behind your two rabbit-like front incisors. A lateral branch, of course, innervates the nasal conchae. So from this one space, sensory distribution is completely passed around through the face. Taking advantage of these passageways, the seventh cranial nerve, facial, has an anterior branch, the greater superficial petrosal, which courses forward bringing with it two modalities. And we'll look at this again, but this is greater superficial petrosal. And this is joined, of course, by a twig from the periarterial carotid plexus, which is sympathetic. The preganglionic parasympathetics synapse in a ganglion, the pterygopalatine ganglion, which is suspended from 5-2. And postganglionic parasympathetics are then distributed by all of these pathways, inferiorly to glands in the palate, salivary glands, soft palate, hard palate, laterally to salivary glands in the gums, anteriorly via the infraorbital, the zygomatic, the zygomatico-temporal, and ultimately shooting for the lacrimal gland. Secretomotor innervation, powering the lacrimal gland, making you tear, is derived from facial nerve 7 via the greater superficial petrosal nerve, which gains access to the pterygopalatine fossa through the pterygoid canal, follows the infraorbital zygomatico-temporal to the lacrimal. And, of course, although I won't draw it, you can imagine that the sympathetics follow all of these pathways. Finally, postganglionic parasympathetics course medially into the nose. Where they generously innervate mucosal glands within the nasal cavity. And sympathetics will follow them as well. The modality of taste is conveyed from 7, but unless you're enterprising enough to develop taste buds in your nose orbit, it's unlikely they will do you very much good, or even on the upper teeth, do you very much good in any place save the soft palate and the hard palate. There are taste buds on the soft palate and hard palate. One sensory entrance, 5-2. Distribution in 4 directions. Preganglionic parasympathetics, postganglionic sympathetics, and taste through another passageway, the pterygoid canal, and distributed for the most part in those 4 directions. And finally, if we understand that, we can take the termination of the maxillary artery, which lies here in the infratemporal fossa. Here is the maxillary artery in the infratemporal fossa, and that passes through the pterygomaxillary fissure, like this. As it does so, it gives off, now I'm going to start to repeat myself, it gives off a posterior superior alveolar branch, and then within the pterygopalatine fossa, of course, it's going to send off a greater palatine branch, an infraorbital, and, of course, a sphenopalatine branch. The nose is well vascularized, as you know. 1, 2, 3, and 4. Again, those 4 areas are covered basically through the pterygopalatine fossa. There are 2 smaller branches there that go into the pterygoid canal, and this pharyngeal branch through the palato-vaginal canal will reach the roof of the nasal mucosa, the pharyngotympanic tube, auditory tube, and the sphenoid air cells. Key spot. Entered behind from the foramen rotundum and the pterygoid canal, and laterally by the pterygomaxillary fissure. Bring everything in there, distribute it all around. Let's go back to the second page. And review, if we will, the distribution of the 3 divisions of the trigeminal nerve. Some years ago, in drawing these generic anatomical faces, became dyspeptic and bored. And I had in my class that year an individual. Is he here? He's not here. We shall call him S. S was a wonderfully bright, intellectual slob who 5 or 10 minutes into my lecture would come staggering in, and he'd kind of look at me, and he'd kind of look at the stuff and scratch himself and sit down. You know, he did this day. I never had his shirt tucked in or anything. And, you know, he didn't shave. It was nothing. So I took it out on him. I put his face up on the board, and I drew on it. It was great. And then I had a student in a subsequent year, and she was a very interesting student. She was also extremely bright. Very able dissector. Ran one of the most extraordinary dissecting routines, along with her colleagues at that table, that we have ever witnessed in HST. Her communication skills were interesting, novel to me. Well, not entirely novel to me. I mean, I'd been to Australia, all right, and I know they like to hit a lot there, and of course, I have to admit, I've never been hit so many times by a student in my life, and of course, you know I'm not allowed to hit back. Okay? She went to the board, all right? Now this year I have a special problem. This year's class is an assemblage of the not only most intellectual, but kindest, most gentle people I've ever known. That's all senior students laughing. You know, the milk of human kindness courses in their veins. They deport themselves in a perfectly ordered and reasonable manner. There's not a rascal in the crowd. There's nobody I can punish. This is extraordinary. Who should I pick out? There might be one individual who, although not a rascal himself, I suspect wants to be a rascal. He's a kind of a covert rascal. I've kind of watched him. And so he is this year's representative. And you know, I'm not castigating him. His deportment throughout this semester was exemplary. Nonetheless, it's Shashank, the ready anatomist. Where is he? Where are you, Shashank? Oh, there you are. I was hard pressed early this morning. It doesn't really look quite like you, but it was the best I could do given the circumstances. But now, let's have at it. Let's have at it on his face. If we look at 5-1 now, we would recognize here. Now, watch this, folks. I'm going to use yellow for high contrast. You use blue on your notes. Switch to blue. Bravo, Lima, uniform, echo. All right. Here we go. There, Shashank shows his lacrimal nerve. Here, up through his curly hair, the supraorbital, supratrochlear, infratrochlear, and external nasal, covering this entire region. And of course, this particular shaved individual, this 5-1 area, extends to the crown of the head. So this is all 5-1 or ophthalmic territory. 5-2, you will recall, appears here as infraorbital, which takes the lower lid and extends down across the cheek to the upper lips. This is the infraorbital. In addition, there is a zygomaticofacial here and a zygomaticotemporal, as indicated on your. I've written all this out, so I'm not writing them down on the board. Finally, 5-3, of course, has a number, 3 to be exact, of major cutaneous branches. One of them is the inferior alveolar, which enters the inferior alveolar foramen, traverses the entire mandible, and appears here out of the mental foramen as the mental nerve. The rest of the cheek jaw is taken by the buccal branch here of 5-3. There's the buccal branch. And the third branch of 5-3 is the auriculotemporal, a branch that takes the upper part here of the ear and this temporal region like that. So, 5-3, and here is 5-2 territory. You notice that this is the only representation, cutaneous, large representation of cutaneous cranial nerves in the head and neck, because everything else is non-cranial nerve. Point 1, cervical nerve 1 has no dermatome. These follow in regular metameric order: the lesser occipital, the greater occipital, the great auricular, the transverse cervical. I didn't label this area, but what is it? Does anybody remember? So yeah, go ahead. You almost had it. Yeah, Ryan, Mr. Lanning, he's fabulous. Supraclavicular, that's right. That's supraclavicular. Good for you. And these are C2, 3, 4, C2, 3 innervation of the back of the head, side, back, and front of the neck. Seven. The seventh cranial nerve, you'll recall, the seventh cranial nerve exits the posterior cranial fossa by the internal acoustic meatus, and following this canal laterally sends its major motor, read yellow, motor branch like this, laterally, and then posteriorly, and then inferiorly to exit the stylomastoid foramen. This motor division of 7 is responsible for the muscles of facial expression via its branches, which, like the fingers of a hand, project from the mastoid process across the face: temporal, zygomatic, buccal, mandibular, cervical, innervating all the muscles of facial expression, including the platysma, but even more important, people tend to forget this one, the buccinator. The buccinator is a very important muscle. Yeah, see, the older, more knowledgeable students are sitting there smiling. Yeah, they know this. Or they just know I like the buccinator. The buccinator is extremely important when you lose it through Bell's palsy, facial paralysis, because you tend to get food trapped out in the buccal recess out here, and you can't get it back. What are you going to do? I mean, you're sitting there eating over there, put your finger in your... No, that's terrible. It's hard for people. So the buccinator is an important component in the facial nerve field. There are some other nerves, the posterior auricular. Those of you who can wiggle your ears enjoy that nerve. Not everybody can. And also the stylohyoid and the posterior belly of the digastric are served in motor capacity by facial 7. As it passes downward toward the stylomastoid foramen, the facial nerve gives off a little branch which innervates the stapedius muscle. However, there's some other components to the facial. One is taste, brown. Taste fibers accompany the facial nerve and are bipolar neurons, the bodies of which gather at this bend, or genu, to form what is called the geniculate ganglion. Taste fibers then course posteriorly, inferiorly, and just before the facial nerve is about to leave the stylomastoid foramen, they jump back through a small canal into the middle ear cavity. This is the petrous portion of the temporal bone, and here's the lateral wall of that cavity. And that's the tympanic membrane. This little filament, the so-called chorda tympani, crosses the tympanic membrane and exits the middle ear cavity via a tiny canaliculus. It is at this point that the chorda tympani decides to jump on a major branch of 5-3, which is the lingual nerve, headed to the tongue and providing sensation to the anterior 2/3 of the tongue. You bite your tongue, you're biting and feeling it through the lingual nerve. However, the taste fibers jump on to the lingual nerve and thus make their way to the anterior 2/3 of the tongue. Anterior 2/3 of the tongue. Taste is mediated by 7 via the chorda tympani. Accompanying that modality is our preganglionic parasympathetics. Preganglionic parasympathetics and suspended from the lingual nerve is the second of the 4 pairs of parasympathetic ganglia. This is the so-called submandibular ganglion. Synapse takes there with postsynaptic bodies, and their axons then are conveyed via the lingual nerve to the submandibular gland, the sublingual glands, and other salivary glands in the tongue and the floor of the mouth and the cheeks. Chorda tympani then is a branch of 7 that is conveying taste to the anterior 2/3 of the tongue and preganglionic parasympathetics to various salivary glands. This pathway is then duplicated in another direction. Preganglionic parasympathetic taste fibers run forward in their own little canal and emerge in the middle cranial fossa as the greater superficial petrosal nerve. This nerve we now know about. It will take a branch here of the sympathetic plexus, which is postganglionic, and that is the so-called deep petrosal nerve. These three modalities running together are the Vidian nerve, or the nerve of the pterygoid canal. We've already spoken about that in terms of 5-2, entering the pterygopalatine fossa and being distributed therefrom. The taste fibers here from 7 are conveyed by the greater and lesser palatine canals, of course, to the hard and soft palate. That is 7. Professor David, gentlemen, you want to move over there because it's going to be very difficult for you to see. You've already had difficulty seeing through me, right? But I would sit in that little row there. Because I sat there and looked at those drawings and I could hardly see them from there. There's some empty seats. I mean, I know you guys need good notes. That's why I'm working on it. All right. Nine. Nine, you will recall, exits the jugular foramen along with 10 and cranial 11. And what we find just below that foramen is a ganglion. The ganglion of the glossopharyngeal nerve, and this ganglion has two parts, so I'm only going to draw half of it as a hemisphere, but it is sensory. And in this ganglion are cells conveying, general sensation. Let's talk about that. General sensation from the posterior third of the tongue. So there's the posterior third of the tongue. And from the fauces, now these fauces, remember, are the little arches that flank the tonsillar bed. You look in somebody's mouth and you see a pair of Gothic arches. The one that you see first is actually the muscle palatoglossus. The one you see deeper in is the palatopharyngeus, but we tend to call them both the fauces. So sensation is applied to the fauces, and then sensation is delivered here to the soft palate. There are also sensory branches that pass to the carotid sinus and carotid body, which are respectively baro and chemoreceptors. The other half of this ganglion represents cells having to do with taste. And these taste fibers are, as with the sensory fibers, conveyed to the posterior 1/3 of the tongue. So the anterior 2/3 you're tasting with facial 7, the posterior third you're tasting with glossopharyngeal 9. There is only one stinking, small, seemingly inconsequential muscle that receives somatic innervation from glossopharyngeal, and that is stylopharyngeus. Stylopharyngeus. 9 has other involvements, though. As soon as 9 appears out of the jugular foramen, 9 sends a little branch right back up into the bone. It is sensory, and you can see this if you look on the margin of your jugular fossae this weekend. If you have nothing else to do, look for this. It'll keep you fascinated for hours. Up through an inferior tympanic canaliculus. This so-called tympanic nerve, or nerve of Jacobson, thus gains access to the middle ear cavity between the petrous portion of the temporal bone and the lateral wall, which houses the tympanic membrane. And it makes, in this area, a sensory plexus that covers the entire area, from the pharyngotympanic tube, the walls of the middle ear cavity, the inner surface of the eardrum, back into the mastoid air cells. This is the tympanic plexus. Pure sensory, period, from 9. However, conveyed with that are some preganglionic parasympathetics, which follow Jacobson's tympanic nerve and so enter the middle ear cavity. However, they haven't got anything to do in the middle ear cavity except go right through it. And they pass out it anteriorly through another small, hard-defined canaliculus and appear in the middle cranial fossa as the lesser superficial petrosal nerve. Now, you remember the greater superficial petrosal nerve, they're running right alongside each other, was that passing from 7 to the pterygopalatine fossa. Here is the lesser superficial petrosal nerve, and it's heading right toward foramen ovale. The mandibular division of the trigeminal exits here, 5-3, and one of its branches is going to be a major branch to the ear, upper part of the ear, and the temporal region. Hence, it's called auriculotemporal. And it happens to pass through the parotid. This continuation of Jacobson's nerve then passes either through its own little canal or through the foramen ovale itself, and finds the third of these ganglia, the otic ganglion. This, as in the case of the others, is an area for synapse with postganglionic neurons, which are then conveyed by the auriculotemporal to the parotid. To the parotid. The vagus, the wanderer, the nerve you first saw, the nerve you will last see. The nerve that has an enormous span across the body from, as we will see, the ear to the left colic flexure. The vagus nerve also exits the jugular foramen with 9, and it You should have had a hydrant. Yeah, the presence of cameras often induces me to do really bad things. Get that? Yeah, there's enough in me that really wants to do something awful. 10, yes, right. 10 just below the jugular foramen has an itty-bitty little ganglion. It's a cute little ganglion. In fact, I don't think I saw it this year. People held it from me. But from that tiny superior ganglion, their cells send processes through the anterior tympanic canaliculus, and so some sensory representation is provided by the vagus nerve to the anterior part of the external auditory meatus and the external surface of the tympanic membrane. And irritation in this region can have a vagal effect and induce gastric reflux. You can induce vomiting. You can get sore stomachs from this. Check children who report with gastric symptoms. They just may have something stuck in their ear. Always look in ears because of the vagal distribution there. Now, there is a much larger ganglion, the inferior ganglion, that hangs below that. From that ganglion, afferents, or afferent processes, are passed to the carotid body. So the vagus is connected with the carotid body, but not the sinus, whereas 9 has both branches to body and sinus. Likewise, the vagus has an enormous representation of afferents. And let's break this here. So as to not make this diagram too complicated. An enormous representation to the rest of the gastrointestinal system, starting at the esophagus, the stomach, the lungs, the heart, and the gastrointestinal system to the left colic flexure. So there goes that part of the vagus that is carrying sensory afferent, visceral afferent information back to the central nervous system. And we know, of course, that that part of the vagus likewise provides a conduit as a major parasympathetic nerve. Another branch of the vagus will be the superior laryngeal, which will divide into an external laryngeal and an internal laryngeal. And the internal laryngeal will be responsible for innervation, sensory innervation, of everything behind the epiglottis and above the vocal folds. there is, in addition, associated with this inferior ganglion, taste fibers. And these taste fibers will run to glands of taste, organs of taste, on the epiglottis and in the area of the valleculae. The valleculae are two tiny little pockets in the tongue, just in front of the epiglottis and on either side of the glossoepiglottic midline fold. So there are the taste fibers. As you know, a branch of the vagus recurs, and that is the recurrent laryngeal, which would come off way down here and ascend to provide sensory innervation to the larynx below the level of the vocal cords, because after all, the internal laryngeal provided sensation above the vocal folds. But is that all? Here comes the most difficult part. Sometimes Ed Gilland and I fall to confrontational fighting right there in the amphitheater pit. It's ugly. It's not what gentlemen should do, but it's not well known. But I'm going to represent it to you one way. It's my way, and it's correct. There is some doubt about this. There's been relatively little research into it. But the question is the source of the somatic motor fibers that course with the vagus. The best indicators are that they are most, if not all, and it's that phrase that gets people going, derived from the nucleus behind the vagus, which is the nucleus of cranial 11. Now you will remember, ladies and gentlemen, that the 11th nerve is a real fake-out, the accessory nerve, because you've got to ask immediately, do you mean spinal accessory or do you mean cranial accessory? If you mean spinal accessory, then you mean not a cranial nerve at all, but a peripheral nerve with an aberrant course. A peripheral nerve that rises from C1 through C5 levels, flows up through the neural canal, through the foramen magnum, exits the jugular foramen, and heads where? To the trapezius and sternocleidomastoid. Yeah? See, you even remember it, Tech. It's fantastic. This stuff sticks. Cranial 11 is from rootlets behind the origin of the vagus, but it joins the vagus. And these are motor fibers that are represented in branches of the vagus. These motor fibers provide innervation to muscles of the soft palate, i.e. the musculus uvuli, you know, the thing you can, right? Little floppy thing like that. It's a thing that when I see one on a polar bear, then I know I really must use my pistol. I mean, it's the best shot you can have, actually, a uvula shot. It's really good, but the muscles of the soft palate, the musculus uvuli, and the palatoglossus, for example. palatopharyngeus. And muscles here of the pharyngeal constrictors. Likewise, motor branches, motor components accompany the superior laryngeal nerve and contribute to the pharyngeal plexus and provide innervation to one muscle, cricothyroid, one laryngeal muscle, cricothyroid. And that is from the external laryngeal branch of the superior laryngeal. Finally, motor fibers accompanying the main stem of the vagus. Following it into or nearly to the chest on the left side, recurring, leaving the vagus and recurring around the right brachiocephalic, or in the case on the left side, around the left, what? Ductus arteriosus, ligamentum arteriosum, as the recurrent laryngeal nerve. And the recurrent laryngeal nerve then enters the larynx internally and provides motor supply to every laryngeal muscle that you can think of except the cricothyroid, which you've already taken care of. And so it is generally believed that most of these motor fibers, if not all, that accompany the vagus are derived from cranial 11. You can go arm wrestling then whether cranial 11 really is just part of the vagus. And I don't care. They are separate little fibers aligned with the vagus. One of my favorite operas, Pagliacci, Canio, at the very end, sings the great La commedia è finita. The comedy is finished. The show is over, ladies and gentlemen. Thank you very much. Bless you all. Couldn't do this. Thank you. You'll hurt yourselves. Thank you. Well, see? That's how they feel. Yeah, they got students. You go out there. That's how they feel. Well, thank you. Thank you. We'll have a break. We'll have a break, ladies and gentlemen, before we hear our next lecture on Dr. Varese on head and neck surgery. Thank you so much. It was very touching. I appreciate that. Nice to see you all.